Hello future engineers and my dear students, welcome to MUDASSIR Academy. I have already uploaded the model question paper solutions for 1BMATE101 and 1BMATE101. However, I was left with 1BMATE101 and due to some health issues, I sincerely apologize for delaying in uploading the paper. So today we will be solving the model question paper 1BMATE101 completely. I strongly recommend you that you devote at least 3 to 4 hours to this model question paper along with the videos on my channel, and please do follow the Instagram page and Facebook page for the all most important questions on all the modules from 1BMATE101. So together it forms a very essential and a very effective question bank. It will be extremely helpful from the examination point of view to boost your confidence and score 80 to 90% or even 100% marks. And remember, last minute study for engineering always works. So let's start solving the model question paper for 1BMATE101. So see, the first question is module 1, that is question A. With usual notations, prove tan phi is equal to r d theta by dr. The mostly asked question for 6 marks is the theory derivation. I have already solved the derivation, so please check the link in the description below. The second one is also very important. Question 1b. Show that the angle of intersection of the curves r is equal to a log theta and r is equal to a by log theta is tan inverse 2e by 1 minus e square. Or they may simply ask, find the angle of intersection between the curves r is equal to a log theta and r is equal to a by log theta. A very important, most frequently asked question in the VTU examination. So question number 1b, I have already solved it. So please do refer the link in the description below. The third one is question 1c. Show that radius of curvature at x is equal to pi by 2. I solve it here. So question number 1c. Show that the radius of curvature, I am writing short form, at x equal to pi by 2 of the curve y is equal to 4 sin x minus sin of 2x is it's 5 root 5 by 4. Okay, so let's solve this question. So as you know, the radius of curvature, this is Cartesian curve. Wherever we have x and y, it's always Cartesian curve. So the radius of curvature is given as ROC, rho is equal to 1 plus dy by dx whole square whole raised to 3 by 2 upon d square y by dx square. That means we need to find dy by dx and d square by dx and put it and get a solution. So we have the question y is equal to 4 sin x minus sin 2x. That is dy by dx will be here. So it's a very simple differentiation. 4 cos x minus 2 cos 2x, right? Okay, so now see, dy by dx at, they have mentioned a point pi by 2. That means dy by dx at the point pi by 2 is equal to, see, in place of x put pi by 2, so obviously it will be 0. Why? Because cos 90 is 0 and again cos, okay, it is 0 minus 2 into, see carefully, cos in place of x put pi by 2, 2 into pi by 2, 2 cancels. Cos pi, okay, I write here 2 cos pi. So what is the value of cos pi? Cos pi is always minus 1. Remember it. Therefore, dy by dx at x is equal to pi by 2 is equal to 2. Fine. So we got dy by dx here because cos pi is minus 1. Similarly, let's find d square y by dx square. So d square y by dx square will be, again differentiate this. See, 4 into differentiation sin cos x is minus sin x minus differentiation of the derivative of cos x is minus sin x, but cos 2x is minus 2 sin 2x. So 2 to the 4 minus 4 sin 2x. Therefore, d square y by dx square at the point x is equal to pi by 2 will be nothing but, so in place of x put pi by 2, as you know sin 90 is 1, sin pi by 2 is 1, so minus 4 minus, see here, 2 into pi by 2, 2 cancels. What is sin pi? 0. Sin pi is always 0. So we have it as, so we can write d square y by dx square at x is equal to pi by 2 will be simply minus 4. So we have both the values now. That implies rho is equal to, this will be 1 plus, so formula is dy by dx whole square to 2 square whole raised to 3 by 2 upon d square by dx square is minus 4. Fine. So that will be nothing but 1 plus 4, that is 5. phi raised to 3 by 2 upon minus 4. Okay, so phi raised to 3 by 2 can be also written as phi into phi raised to 1 by 2, am I right, upon minus 4. Okay, therefore rho is equal to nothing but phi root phi, because see phi raised to 1 by 2 is root phi upon minus 4, as radius of curvature is always positive. Therefore the radius of curvature we can write modulus of rho is equal to phi root phi by 4. That's the answer. So am I right? So that's what they're asking the solution here. That's it. Okay, simple question for 7 marks. Okay, so let's move on with the next now. Question 1R A. With usual notations prove that 1 by p square is equal to 1 by r square plus 1 by r raised to 4 dr by d theta the whole square, derivation for 6 marks. This is nothing but derivation for perpendicular distance between pole and tangent, and along with the question A I had derived this also, so please do refer the link in the description. Next one is question B. Find the angle of intersection of the curves r square sin theta is equal to 4 and r square is equal to 16 sin theta. Very important question from angle of intersection. So we need to find phi 1 then phi 2, subtract it. This problem also I have solved, so please do refer the link in the description. The next one, find the radius of curvature using pedal form for the curve. Let's solve this. Okay, I solved like this. One more question is there, but they are given second on the right side, so this question is really different. So question number 2C is, it's find the radius of curvature using pedal form for, what's the curve given, r square secant 2 theta is equal to a square. Okay, so the simple idea for finding pedal equation is we find angle phi first, that is the pedal equation is what p is equal to r sin phi. So first we apply log on both sides. Apply log here, we have log of r square into secant 2 theta is equal to log of a square. Okay, r square into, fine. Now log a into b, log a into b is log a plus log b. So this is log r square plus log secant 2 theta is equal to log of a square. Again the principles of logarithm says, see, we want everything plane on the ground. Nothing should be raised to when solving problems in applied mathematics, solving the required results. Everything should be plane, no power or no multiplication allowed. So this is okay, but this log r square, log a raised to k is k log a. So 2 log r plus log of secant 2 theta is equal to 2 log a. Okay, now everything is okay. Now differentiate is for theta. 2 into differential 1 by log r is 1 by r dr by d theta, plus again derivative of secant is, see, log of x is 1 by x, so secant will be 1 by secant 2 theta. Again differentiation of chain rule, secant x is secant x tan x, so secant 2 theta will be secant 2 theta into tan of 2 theta into 2 is equal to 0. Okay, secant cancels, 2 also cancels here. So what is the cot? We write 1 by r dr by d theta in polar form as cot phi, standard expression. So we take tan that side to become minus tan 2 theta. Now since both the LHS and RHS should be same, it should be cot to find angle phi. So how do you write minus tan in terms of cot? Minus tan theta is equal to cot of pi by 2 plus theta. So please do refer the videos on this. I have given all the, discussed everything in detail, the formulas and everything, how to apply them. So minus tan theta is cot pi by 2 plus theta. So I can write it as cot of pi by 2 plus 2 theta, because there is 2 theta here. So here again see cot cancels. So the angle phi is equal to pi by 2 plus 2 theta. So better underline this, because you are going to get step marks here. Okay, if you make mistake in finding phi, then obviously you get 0 marks. Okay, be careful about it. So you get phi here. Now the pedal equation is given as p is equal to r sin phi, that is equal to r sin of pi by 2 plus 2 theta. And what is sin 90 plus theta? So because see, p is equal to r sin phi, phi is the angle which you found here. In place of phi put pi by 2 plus 2 theta. Sin 90 plus theta is cos theta, so it is cos theta. So we have P is equal to R cos of 2 theta is the pedal equation. Fine. So we have the pedal equation now. Now this is equal to, that implies now, so remember pedal equation should be constant. Should be what? Constant. Always. Pedal equation is always constant. Is the length of perpendicular from pole to tangent. So P is equal to R cos theta. I don't want this cos 2 theta here. So where should I get the value of cos theta? From the question. See, from the question here we have, I write here, we have R square secant 2 theta is equal to A square. So secant 2 theta is equal to A square by R square. But I need here cos 2 theta. That means cos 2 theta will be R square by A square. That's all. Getting it? Therefore, we can simply write here pedal equation is always constant. That's why we find the value of cos theta from the question. Okay. See, R square secant 2 theta. We want the value of cos. Secant is 1 by cos. So ulta, inverse. Cos 2 theta is R square by A square. That implies pedal equation P is equal to R into cos 2 theta is R square by A square. Okay. So P is equal to R cube by A square. Please underline this also. You are going to get step marks for this. Okay. So we have the pedal equation now. Now from this pedal equation, find the radius of curvature using pedal form. So the pedal ROC, pedal form is rho is equal to R dr by dp. What is that? R dr by dp. This is the pedal form. So here note that we already found P here. See, R dr by dp. So we know P. So what I'll simply do, I will find dr. See, we need dr by dp. I have P here. So what I'll do, I'll first find dp by dr here. So from this implies dp by dr is equal to directly dp by dr will be 1 by A square as it is. Differentiate respect to R. Differentiation of R cube is what? 3R square into 3R square. Done. Therefore, that implies rho is equal to R into C. dp by dr is 3R square by A square. So dr by dp is A square by 3R square. So R cancels here. That is A square by 3. That's all. Therefore, rho is equal to A square by 3 is the solution. That's it. I hope you understood this. Okay. Check it once again. So we find, okay, please verify it. So P is equal to R cube by A square. So we have dr by dp, right? So 3R square by A square. Fine. So rho is equal to R dr by dp. A square by 3R square. Yeah, R cancel. So A square by R is the solution for this question. So now let's move on to the next one, that is module 2. Fine. So module 2 is question 3a. Expand log secant x in powers of x as far as the term x is to 4. A very compulsory question. They will repeat same question in the examination. So please, I have already solved the question here. So please do refer the link in the description. So next question 3b. Let's move to the solution of question 3b. That is, if u is equal to f of y minus xy, comma z minus xyz, prove that x square dou by dou x plus y square dou by dou y plus z square dou by dou z is equal to 0. Important problem from composite function. First time this has been discussed in the video paper, model question paper. Okay, so we'll do it here now. The problem here can be solved using chain rule. And see the question here, u is equal to f of y minus x by xy, comma z minus x by xz is a composite function. So let's understand it in a very simple way, how to find the partial differentiation using chain rule for this composite function. So please, as I always tell, please keep your notebook and pen ready and practice along with me so that you never miss any step here. Okay, so now we have here, so what I will do, see, first thing what I will do, since it is a composite function, I cannot solve directly, there is a comma here. What I will do, simply assign this as P and this as what? QC. Okay, I write here, see, I write let P is equal to y minus x by xy and q is equal to z minus x by xz. Okay. Now to make it more simple, I can rewrite this here, y minus x by xy. See, whole divided by xy, I can separate it. Y by xy, y cancels. This becomes 1 by x minus x by xy, xx cancels, 1 by y. Very simple, correct? Next, q is equal to z by xz. See here again, z by xz, z cancels, we get 1 by x minus x by xz, because a plus b upon c is a by c plus b by c. Okay, simple basics. Z minus x by xz is z by xz, z cancels, 1 by x minus x by xz, x cancels, 1 by z. Now see here, what I have taken here for this composite functions, p is equal to y minus x by xy and q is equal to z minus x by xz, correct? Now you can write this as u is function of what? P and q. U is function of P and Q. But P and Q is function of what? P is written in terms of x, y and z. P and Q is written in terms of x, y and z. Therefore, U is a function of P and Q. P and Q is a function of what? X, y and z. That's it. That means U is a function of P and Q. P and Q is a function of x, y and z. That means U is a function of x, y, z. So in a very simple terms, I'll explain like this. See, listen carefully for you to remember. U is a function of P and Q. P and Q is a function of x, y, z. That means U is a function of x, y, z. Let's say U has two wives, P and Q. P and Q has three children, x, y, z. Then obviously U is a father of x, y, z. That means you will have three children. One child is x, dou u by dou x. Other child is y and z. That is, one child is dou u by dou x, other is dou u by dou y, and the other one is dou u by dou z. As simple as that. Getting the point here. U has two wives. Two wives has three kids, x, y, z. Then obviously U is a father of x, y, z. So we write as three partial derivatives: dou u by dou x, dou u by dou y, dou u by dou z. And this with respect to, see, dou u by dou x, first child x, with respect to two wives. Who are the wives? P and Q. Getting it? That means I can write this as, see, I want dou u by dou x only. This should be retained with respect to P and Q. So how I write the chain for this, the chain rule for this? See, very simple. Dou u by dou x with respect to P and Q is equal to dou u by dou P into dou P by dou x. Dou P cancels. What remains? Dou u by dou x plus again second is Q. So dou u by dou Q into again dou Q by dou x. That's it. Simple, right? So I'll show you next also here. Dou u by dou y will be similarly same thing. Second child y with respect to two wives. So again dou u by dou P into dou P by what? Dou y. See, dou P cancels. Dou u by dou y retain. Again here with respect to Q, dou u by dou Q into dou Q by dou x. Dou Q by dou y. Okay, dou y. And the last one, dou u by dou z will be how much? Dou u by dou P into dou P by dou z plus dou u by dou Q into dou Q by dou z. That's it. I hope it's clear now. Correct? See, dou P cancel, dou Q cancel. What remains? Dou u by dou z. This is how we write the chain rule. Very, very simple way. Okay, understand like this. Now, let's find the partial derivatives here. So, we need here dou u by dou x, dou u by dou y, dou u by dou z. Correct? So, we got all this. Now, dou u by dou x will be equal to dou u by dou P, I don't know. Keep it as it is. Dou P by dou x. See, again, differentiate partially p with respect to x. I written it very simple way. Y minus xy is 1 minus xy minus 1 minus y. Okay, see how simple the differentiation becomes now. Dou p by dou x, p is 1 by x minus 1 by I. As I told you, as I always keep on telling, very simple thing, differentiation of 1 by x is minus 1 by x square. As simple as that. Again, listen carefully. Derivative of 1 by x is minus 1 by x square. So, dou p by dou x, 1 by y, 0. Because we are partially differentiating only with respect to y, rest all is constant. Okay. So, derivative of 1 by x is minus 1 by x square. That's all. Plus dou u by dou q, I don't know. Dou q by dou x. So again, q is 1 by x minus 1 by z. Again, 1 by z, no use, because you are differentiating partially with respect to x, z is 0, constant, leave it. Again, x is here. Derivative of 1 by x with respect to x is, because dou q by dou x is again minus 1 by x square. That's all. And that implies now, see, we'll get directly the things here. What they are, see, in the problem, they are asking to prove x square dou e by dou x plus y square dou e by dou y plus z square dou e by dou z is equal to 0. So we can easily find here first term, we have this dou e by dou x, you can easily find x square dou e by dou x. So that implies x square into dou u by dou x will be equal to what? See, multiply by x square here. And it's very simple thing. When I multiply by x square, see, x square cancel, x square cancels here. Because x square is in the denominator, it will cancel off. So what remains? Minus is there. So minus dou e by dou p plus minus dou u by dou q. Okay, that's it. Similarly now, dou u by dou y will be equal to how much? See, here also dou u by dou p as it is into dou p by dou y. So what is dou p by dou y? P is 1 by x minus 1 by y. Since we are differentiating p with respect to y, 1 by x constant 0, no use. 1 by y is there, p is 1 by x minus 1 by y. So dou p by dou y, p with respect to y is again differentiation of 1 by y is what? Minus 1 by y square with respect to y. So minus into minus become plus. So I get 1 by y square. That's it. Clear? Similarly, dou u by dou q. You got it right? See one more time. I am explaining you. Dou u by dou p as it is. Don't touch it. Dou p by dou y. Differentiation of p partially with respect to y only. That means, what is p? 1 by x minus 1 by y. So you are differentiating p with respect to y. So 1 by x is constant 0. 1 by y is there. What is the differentiation of 1 by y? Differentiation of 1 by x with respect to x is minus 1 by x square. That means differentiation of 1 by y with respect to y is minus 1 by y square. Correct? No? Simple. So minus minus become plus. So 1 by y square. That's it. I hope it's clear now. Okay. Plus dou e by dou q into dou q by dou y. What is q? 1 by x minus 1 by z. Is there any y term here? No, there is no y term. Obviously, these are constant. So what is that? 0. Differentiation of constant is 0. No y terms at all. 0. Again, that implies now y square dou u by dou y. So y square into dou u by dou y equals 2. That is what? Y square into, see here, this is 0, leave it. Y square denominator cancels. So we get only dou u by dou p. That's it. Done. Now the last one is dou u by dou z is again dou u by dou p I don't know. Leave that as it is. Into dou p by dou z. So what is p here? Clearly 1 by x minus 1 by y. Dou p by dou z, derivative of p with respect to z, and there is only x and y, no z terms. So what? 0. That's it. So differentiation of p with respect to what? Z is here 0. Plus again dou u by dou q, I don't know, into dou q by dou z. See q. What is q? 1 by x minus 1 by z. 1 by x, I am differentiating with respect to only z here. So x, no use, 0. Derivative again 1 by z is minus 1 by z square. There is minus here. Minus to minus become plus. So plus 1 by z square. Okay, this is what we get here. That implies what we need, z square dou u by dou z. So z square into dou u by dou z equals, when I multiply this is 0, z square is in the denominator. So z square cancels. We get only plain dou u by dou q. Interesting, right? Okay. Now let's add all these things. We have with us x square dou u by dou x. We have y square dou u by dou y. We have z square dou u by dou x. Let's add it and see what the solution is. Let's add all these things here. So that implies x square dou u by dou x plus y square dou u by dou y plus z square dou u by dou z will be equal to what? Minus dou u by dou p minus dou u by dou q plus dou u by dou p plus dou u by dou q. That's what we have here. So when I add all these things, this cancels. And what's the answer? Answer is 0. That's all. Now moving on to question 3c. So the question 3 says, examine the function for extreme values. F of x comma y equals x³y² into 1 minus x minus y. Okay. So apart from this, I have solved some other questions. You please find those videos on my channel. Those are also very, very important. Please practice those also 2-3 questions. They are very important along with this. Okay. Fine. So let's solve this question now. And one more thing, please, after the examination, please don't forget to send your question papers. My WhatsApp number and my email ID is given in description. Please do that. Okay. It will be beneficial for other students in future. Now, examine the function for extreme values of question on maximum minima. Okay. So first what we do, I will write this as, okay, f of xy is equal to, let's open a bracket, x³y² minus x⁴y² minus x³y². Always for finding the maximum minima, we first find fx, partial differentiate with respect to x, then partial differentiate with respect to y. Okay. After partial differentiation of x and y, we assign fx is 0, fy is equal to 0, and we find the stationary points from which some are maximum, some are minimum, some are don't care. Okay. So the question is, okay, let's get. So what do we do here first? We find fx. Fx is equal to partial differentiate with respect to x. So y square as it is, don't touch it. Differentiate x square is what? x³ is 3x². Okay. Minus c. Y square as it is, don't touch it. Derivative of x⁴ is 4x³. Correct? So here fx means partial differentiation with respect to x. Y square as it is, don't touch it. Differentiation x³ is 3x² minus y square as it is, derivative of x⁴ is 4x³ minus again c, differentiation x³ is 3x² into y³. Done. Next we have fy. So fy will be equal to similarly partial differentiate with y. So it will be, see, x³ will be as it is. Okay. Differentiation y² is 2y. Correct, no? x³ as it is, differentiation y² is 2y. Then here also minus 2y x⁴ minus 3y² x³. Right? So fy will be 2y x⁴ minus 2y x⁴, 3y². Okay, perfect. Now we assign fx is equal to 0 and fy is equal to 0. So if we assign them, so fx is equal to 0 means, see, remember this value for fx here, okay? We'll be using it later. This value and this value. Now, fx is equal to 0 means what I will do here, 3x² y² minus 4x³ minus 3x² is equal to 0. Here if you see x square and y square are common. So x square and y square are common here. It will be 3 minus 4x minus 3y is equal to 0. Okay. So we get x square y square is equal to 0 and 3 minus 4x minus 3y is equal to 0. Okay. Again here, okay, we have this. So x, obviously x square y square 0 means x is equal to 0, y is equal to 0, and this is one equation. 3 minus 4x minus 3y will be 4x plus 3y is equal to 3. Am I right? Because minus 4x minus 3y is equal to minus 3. So we get 4x plus 3y is equal to 3. Okay. We obtain this solution from it. Now let's see this. We need to find the stationary points, means we need to find the order of pairs. We cannot find from one equation. We have to solve this, and then for one, what's other value of other. So Fy is equal to 0 means we have 2yx³ minus 2yx raised to 4 minus 3y² x³ is equal to 0. Now again here if you see yx³ is common, yx³, this is 2 minus x³, x 2 minus x minus y is equal to 0. Okay. 2 minus, okay, I forgot one thing here, sorry. See this, it is 2 minus 2x, 2 minus 2x minus 3 and x³, right? Okay, y is equal to 0. So from this again we get yx³ is equal to 0, and one more is 2 minus 2x minus 3y is equal to 0. So x is equal to 0, y is equal to 0, and here also 2x plus 3y is equal to 2. So I get this equations here. Now one is already x is 0, y is 0. So you have to know that. Fine. So we have what I'll do, I'll write the pairs here. Okay. So one point is 0, 0. Fine. Next. See, we can solve this both. Let's solve this both first equations. I have this one equation and this one equation, which we can solve simultaneously to get the value here. So this will be 4x plus 3y is equal to 3 and 2x plus 3y is equal to 2. So let's solve this using the calculator. Okay. So better use calculator here. So we go to mode, we go to equation, then simultaneous. It's 4 equals to 3 equals to 3 equals to 2 equals to 3 equals to 2 equals to. So we get 1 by 2 and 1 by 3. Okay. So we get here 1 by 2, x is equal to 1 by 2, y is equal to 1 by 3. That means from this equation, this is independent. Okay. From one equation here and one equation here, I found an order pair. This separate only. So from here, x is equal to 1 by 2 and y is equal to 1 by 3 set of stationary points. 1 by 2 comma 1 by 3. Fine. Now the next remaining is, see, I have one more thing here. See, I got 2 points, but then more point because x is equal to 0 and y is equal to 0. So what I'll do, this x is equal to 0, I'll put here. Okay. So for that, what I'll do, I'll assign this as, say, I'll take this as 1, or I'll take this as, say, okay, I'll do like this. Fine. For your clear understanding, I'll put x is equal to 0 from here in 2 minus 2x minus 3y is equal to 0. If you put x is 0 here, then that implies 2 is equal to how much? 3y. Correct? 2 is equal to 3y. So y is equal to how much? 2 by 3. Therefore, for x is equal to 0, see, what is y? 2 by 3. So one more order pair here. So 0 comma 2 by 3. Again, I'll put y is equal to 0 here. Again, put y is equal to 0 in. See, from here I am putting y 0 in this equation, corresponding pairs. Okay. In 2 minus 2x minus 3y is equal to 0. Again, if I put y is equal to 0 here, see, 0. 2 is equal to 2x. It implies x is equal to 1. That means for y is equal to 0, I am getting x is equal to 1. So pair is what? 1, 0. So right here, again one more pair is 1, 0. Okay, over. Now from here I will put, here also I am getting x is 0, y is 0. So for put x is equal to 0 in, from here in this equation, in 3 minus 4x minus 3y is equal to 0. So when I put x is 0, I get 3 is equal to 3y. So y is equal to 1. So the order pair is 0, 1. Okay. So one more pair I got 0, 1. Lastly, I'll put again y is equal to 0 in 3 minus 4x minus 3y is equal to 0. That is y is equal to 0 from here to here corresponding value. So put y is equal to 0 here, again I get 3 minus 4x is equal to 0. So x is equal to 3 by 4. So for y is 0 means x is 3 by 4. So x comma y, so 3 by 4 comma 0. So we have here 3 by 4 comma 0. Okay, these are all what? Stationary points. So right here, this is all stationary points. Fine. So we found the stationary points here. Now, after finding stationary point, we find A. What is A is equal to f double x. That means partial differentiation of this with respect to x. See x here. Fx is 3x²y² minus 4x³ minus 3x²y³. So A is equal to f double x means fx what you got again differential with respect to x. So this will be 6xy² minus 12x²y² minus 6xy³. Perfect. 6x y³. Okay, right. Next, b is equal to fxy means partial derivative of this x with respect to y. So here see, fx with respect to y means again y² is 2y. So 6x²y, it will be 6x²y minus 2 4 the 8 x³ minus 8 x³y. Am I right? Because differential y² is 2y, 2 4 the 8 minus 3 3 is 9, 9x²y². 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 Okay, fine. Lastly, C is equal to f double y. So what is f double y? Fy again with respect to y, that is dou square f by dou y². Okay. So again here y is constant, so as it is this will be 2x³. Fine. Y is 1. Again here also minus 2x is to 4. Am I right? Because y is 1 again here y², differential y² is 2y. So 6x³y minus 6x³y. So this is what we get here. 6. Okay. Now you know ABC, the condition for maximum minima is as we already discussed in the previous videos also. Please refer the theory for that. The condition is if AC minus B² greater than 0 and A is lesser than 0, that point is maximum point. If AC minus B² greater than 0 and if A is greater than 0, that point is minimum point. And if AC minus B² is lesser or equal to 0, it's invalid. We don't use it. Okay. So here if you see carefully, what I will do is, I will make a table better for your understanding. Okay. So let's take the points here. The points are, okay, I write the values here first. A is equal to 6xy² minus 12x²y² minus 6xy³. B is equal to 6x² minus 8x³ minus 9x² and C is equal to 2x³ minus, because I don't want to get yourself confused, so I am writing everything detailed here, minus 6x³ 6x³ and the condition is AC minus B² should be greater than 0. Okay, so let's write down all the stationary points here along with this. So we have the points 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, so the points here are 0, 0, 1 by 2, 1 by 3, then 0, 2 by 3, 1, 0, 0, 1 and 3 by 4, 0. These are all the points here. Okay, now for these points, let's check the value of ABC and check in the condition. See, this looks little complicated, but I'll show you. It's simple. Why? Because see everywhere there is xy, correct? So definitely, even with a single x or y 0, whole term becomes 0. That means this will be 0 only. Again, see b is equal to, this will be 0 only. Again, this will be 0 only. Correct? So this is 0. So noise. Why? See, again, listen to me. Simple thing to understand here. See, if each and every equation is having what? X and y here. X, y, x, y, x, y. So if any single value is 0, entire thing becomes 0. Am I right? So that's why it is 0. And this I'll solve it, right? And this will be now, because this has a value. Okay. Here also see, this will be 0 only. This will be 0 only. Here x is there, so 0 only. So 0. Okay. And here also see, 0, 0. This also will be 1. See here, and I put a value of 1 here. 2 minus 2, 0. Minus 6 into 0, 0, 0. Don't care. And here same thing will happen here. 0, 0, 0. So this will not exist actually. Okay, because everything has xy terms, so they will not exist. Now, the main thing. Okay, for this, the solution will only exist for this. Okay, so that is for, I write here 1 by 2, 1 by 3, we get A is equal to, what's that? 6 into 1 by 2 into 1 by 3. Okay, 6 into 1 by 2 into 1 by 9, sorry, 1 by 9. Minus 12 into x square, 1 by 2 square is 1 by 4, y square is again 1 by 9, minus 6xy square minus 6 into x is 1 by 2, y cube is 1 by 27. And this value is found to be minus 1 by 9. You can calculate it. Okay. Okay. So similarly, b value will be, so this is minus 1 by 9. Similarly, b value here will be, you can evaluate this 6 into x square. So x square will be 1 by 4 into y is 1 by 3 minus 8 into x cube is 1 by 8 into y is 1 by 3 minus 9 into x square is 1 by 4 into y square is 1 by 9. So this also you can calculate. So the answer is minus 1 by 12. Okay. This is a standard question. So see, usually what I've seen is they won't ask such questions. Sometimes they ask. Okay. So if you want to thoroughly answer this, you can memorize this values and go for ABC. Fine. Now again, lastly, C is equal to 2 into x cube, 2 into 1 by 8 minus 2 into 1 by 16, x is to 4, x is 1 by 2, minus 6 into 1 by 8 into 1 by 3. Correct. Why 1 by 8? Because x cube 1 by 8. So this value is coming to be minus 1 by 8. Okay. Now this value is equal to 1 by 144. So I'll write here all the values. For B it is minus 1 by 12 and it is minus 1 by 1 by 12 and minus 1 by 8, and the value of AC minus B square is 1 by 144 and that is greater than 0. See, the condition is satisfied. So that means, see here A is lesser than 0 and this is greater, satisfied. This we don't take because the compulsory condition for function to maximum minima is AC minus B square should be compulsory greater than 0. If it is lesser or equal to 0, then don't care condition, invalid. So only thus for the whole question there is only one value, that is maximum value. Why? Because here the value of A is lesser than 0 and the condition satisfies AC minus B square greater than 0. So only one value, maximum value. Therefore the maximum value of the function is f maximum is f at what value? 1 by 2, 1 by 3, and that is, let's put in the question here, x cube 1 by 2 cube 1 by 8 into 1 by 9 into 1 minus x minus y. So 1 minus 1 by 2 minus 1 by 3. So answer is coming on 1 by 242. Okay. So answer is, 1 by 432. Answer is 1 by 432. That's the solution. So you can write the maximum value f maximum is equal to 1 by 432. 32. That's all. So this is solution for this question. So if you want to get the answer thoroughly, you need to practice it, and since it is a standard question, as I already told, the same question may repeat in the examination, so you can memorize the value for A, B, C if you want to answer this question. Okay, so that's all. We are done with question number 3C. Now let's move on with question number 3A, that is L'Hopital's rule. Question number 4A. Evaluate limit as x tending to a 2 minus x by a whole raised to tan of pi x by 2a. Okay, this is a L'Hopital's rule problem. So first we'll assign k is equal to limit as x tending to a 2 minus x by a whole raised to tan of pi x by 2a. So what is the L'Hopital's rule? The given, the value is x tends to a. You put the value of a here, so it will be 1 raised to tan pi by 2a. So tan pi is infinity, 1 raised to infinity. Okay. So when we get a form like 1 raised to infinity, 0 raised to infinity, something like this, raised to power infinity, we apply log on both sides. So log k is equal to limit as x tending to a log of 2 minus x by a whole raised to tan of pi x by 2a. Now, as you know, log a raised to k is k log a. So the power of logarithm is it brings whatever things to down. So we have again this as log k is equal to limit as x tending to a tan of pi x by 2a into 2 minus x by a. So as the condition of L'Hopital's rule to apply, the question should be fraction, numerator upon denominator. So we rewrite this as limit as x tending to a. This will be log. So sorry, I have forgotten one thing here. So when you apply log, it will be what? Tan into log of 2 minus x by a. Okay, that's correct. Fine. Now, as I told, the L'Hopital rules condition is the question should be fraction. So again, this we rewrite this as log k is equal to limit as x tending to a. What I'll do is to make it a fraction, I'll keep this log of 2 minus x by a as it is. Okay. See, tan is 1 by cot because 1 by cot is tan. I can write this to make it fraction. I can write tan as upon cot of pi x by 2a. Okay. Now let's put a value here. In place of x, if I put a, x by a by 1, so log 2 minus 1 is 1, so log 1 is 0, but again cot pi by 2 is 0. Fine. So the L'Hopital rule says differentiate numerator upon differentiate denominator separately. So this will be limit as x tends to a. If you differentiate this, say differential log of x is 1 by x, so 1 by 2 minus x by a, fine, into again minus 1 by a, right, whole divided by, am I right? Differentiation of log x is 1 by x, so log of 2 minus x by is 1 by 2 minus x by, again into chain rule, there is x there, 2 is 0, differential minus x by is minus 1 by upon derivative of cot of x is minus cosecant square x. So minus cosecant square pi x by 2a, right, differential cot is minus cosecant square, again differential pi x by 2a is into pi by 2a, differential x is 1. Okay, this is what we get here. Now again if you put the limits here, that implies we get log of k equals to, I think we can put the limits here. Okay, see 1 minus, this will be 1 upon 2 minus 1, right, into minus 1 by a, right, and upon this will be minus c cosecant square. In place of x put a cancels, cosecant square pi by 2, very important point, sin 90 is what? 1, Getting it? Sine pi by 2 is 1. So cosecant pi by 2 is also 1 by sine. That is also 1. So both sine 90 and cosecant 90 are 1. So if you apply it, because here pi, if you apply the limit here, my a and a cancels. Correct? So what remains? Cosecant square pi by 2. Getting it? So minus 1 into pi by 2a. So again here this minus minus cancels. So we get 1 by 1 is 1 only, minus 1 by a divided by, what's that? Pi by 2a. Okay, so pi by 2a. So this will be now 2 goes up, 2 by pi. That's it. So log k is 2 by pi. So by value of k by L'Hopital's rule is e raised to 2 by pi. The perfect solution. So that's it. So the solution for this question is, for the L'Hopital rule, is very important question. And they asked this question many times in the examination. Okay, you can refer it and solve it, practice it. So e raised to 2 by pi is the solution. So next problem is B, question 4b. Question 4b is, if x plus y plus z equals u, y plus z is equal to v, and z is equal to UVW, find dou XYZ divided by dou of UVW. See the question here. Okay. So see the Jacobian, what they are asking. This is question Jacobian. See the question carefully. It is not dou UVW by dou XYZ. If it was dou UVW, it was a very simple question. Directly get the answer. But it's dou XYZ. So dou of XYZ Jacobian of with respect to dou of UVW will be, what's that? X with respect to all, dou x by dou u, dou x by dou v, dou x by dou w. Then dou y by dou u, dou y by dou v, dou y by dou w. Lastly z. Dou z by dou u, dou z by dou v, and dou z by dou w. That's it. But the real problem here is, to find dou x by dou u, dou x by dou u, or dou y by dou u, dou z by whatever, we need x, y, z in terms of UVW, but the question is not given. Only z is there, no issue, but others see. So what I'll do, I'll use my brains. I will, play with these three equations and write equations in terms of x in terms of UVW, y in terms of UVW, and z in terms of UW. That's how I will be able to obtain the solution for this. Okay. So we have here x plus y plus z is equal to u, and y plus z is equal to v, and z is equal to UVW. So here we see y plus z, see y plus z. Correct now. So what I can do is, this y plus z value you can put here. So x plus, what is y plus z? V is equal to u. That means x is equal to u minus v. I got one value. Next, again, see here, again, if you see here, z is equal to UVW. See z. Getting it? That means y plus, what is that? UVW is equal to v. So y is equal to v minus UVW, one more value, and z is equal to UVW is already standard form, so no need for it. That means now we can find dou of x, y, z with respect to dou of UVW as equal to dou x by dou u 1. Why? X is u minus v, partial differential only x with respect to u, so it's 1. Dou x by dou v, see my u minus v, so minus 1. Dou x by dou w, there is no w, so 0. Dou y by dou u, see v 0 only. Dou y by dou u, vw as it is minus differential u is 1. Dou y by dou v, so v is here, see 1 minus uw. Differential v is 1 minus uw as it is, again v is 1. Dou y by dou v. Dou y by dou w, v is 0, so minus uv. Dou z by dou u, vw as it is 1. Dou z by dou v, uw. Dou z by dou w, uv as it is, derivative of w is 1. Now, what to do here? solve the determinant, plus, minus, plus, always do like this, it will be easy for you. For the signs convention, so we have 1 into UV, 1 into this into this, because when you take for 1, we'll use this column and this row, UV into 1 minus UW, minus, see, UV into 1 minus UW, this into this, U square VW, U square VW, because minus is there, become plus, so U square VW. Then next, minus of minus plus 1 into, again, leave this column, leave this row, minus UV square W, minus UV square W, correct, minus, see here, I leave this column, this row, right, so what I got, UV square W minus of minus plus UV square W, plus UV square W, that's all. Okay, now let's open a bracket here, so this will be UV minus U square VW plus U square VW, again minus UV square W plus UV square W. So I think this and this cancels, so it is equal to UV. That's a solution. Therefore we can write, that implies dou of x, y, z, the Jacobian with respect to dou of UV W is equal to UV. That's all. And as I mentioned, this is a very important problem. Okay, this has been asked many times in the VTU exam paper. So please, my recommendation is to practice this question. That's all. So we are done with the question number 4b. Question number 4c is show the differential equation for the current I in an electric circuit containing an inductance L and resistance R in series and acted on by electromotive force E sin omega t. Satisfy the equation L d plus R as E sin omega t. Find the value of the current at any time t if there is initially no current in the circuit. A very, very important question, theoretical question. They can ask this for sure. So I solved this already. The solution you can find discussed below. So now let's move on with the model 3. Question number 5b is solve xy square minus e raised to 1 by x cube dx minus x square y dy is equal to 0. xy square minus e raised to 1 by x cube dx minus x square y dy is equal to 0. So as for the syllabus, you have exact, reducible, exact and linear. So let's see what type is this now. Okay, from here it looks like exact. Let's see. We have m is equal to xy square minus e raised to 1 by x cube and n is equal to minus x square y. That means dou m by dou y will be equal to, we need to partially differentiate with respect to what? Y here. So because the condition for checking to be exact is dou m by dou y should be equal to dou n by dou x. So dou m by dou y will be equal to x as it is, differential y square is 2y. Fine. Similarly, dou n by, because again see e raised to, there is x terms to 0 only. Dou n by dou x will be equal to minus 2xy, because y as it is, different x square is minus 2x. So if you see here, dou m by dou y is not equal to dou n by dou x. That means it is not exact. So when it is not exact, we find a difference dou m by dou y minus dou n by dou x and check if it is close to m or n. So this will be 2xy plus 2xy is equal to 4xy. And if you see, even if I write like this, see, I can write this x square y as x into xy, xy. So it is what? Close to n. Close to n. So when it is close to n, okay, what we do? We find dou m by dou y minus dou n, we find 1 by n, dou m by dou y minus dou n by dou x, 1 by n. So what is n here? Minus xy into 4xy cancels, so minus 4 by x, and if it is close to n, we take this as f of x. From this we find the integrating factor if equal to e raised to, what's the integrating factor for this? It is e raised to integration of f of x dx. That is, integrating factor will be equal to e raised to integration of minus 4 by x dx. So e raised to minus 4 into log x, and from the property log e raised to k log a, what is that? Log a raised to k is k log a, so k log a will be log a raised to k. So this is e raised to log of x raised to minus 4, and one more interesting thing here, e raised to log of something is something. Okay, so I solved the problems on this in a previous model question paper, so please verify that. Those are also important. Fine. So e raised to log of x raised to minus 4 is what? E raised to log of x is x only. E raised to log of x square is x square. E raised to log of something is that something. So e raised to log of this thing will be this e and log cancels. So what remains? X raised to minus 4. So integrating factor is equal to, what is x to minus 4 means? 1 by x raised to 4. Important, underline it. Now if or the integrating factor is a factorial value which when multiplied with the whole question makes it exact, and the solution exact is what? Integration of m dx plus integration of n only y dy is equal to 0 is equal to c. So if should be multiplied by the question here. That implies the question is now, if you multiply 1 by x to 4, so it will be y square by, see, x by x to 4 is y square by x cube. I am writing directly here, minus e raised to 1 by x cube divided by x raised to 4, okay, dx minus x square y by will be y by x square into dy is equal to 0. Now as I told you, the solution is integration of m dx plus integration of n bracket y, means only the y terms is equal to c. No xn all allowed, only y terms are constants. So here there is no plain y term, see x is there, so we don't take it. Correct? If it was only y dy, then take it, or constant. Factor which has multiplication xy is not allowed. Plain y terms are constant. So integration of y cube by x cube minus e raised to 1 by x cube upon x raised to 4 dx is equal to plus 0 dy is equal to c is the solution. Okay, now we need to integrate this. So see, how do you integrate this now? I show it here, the integration. It will be integration of y cube by x cube minus e raised to 1 by x cube upon x raised to 4 dx is equal to c. So let's integrate this. So I will take this as, integration of y cube into x cube. I separate it first. Dx minus integration of e raised to 1 by x cube into I will take this as x raised to minus 4. Okay, dx is equal to c. Now this is easy only. So you are integrating with respect to x, so y cube as it is, and integration x raised to 3 is this is x raised to minus 3, right? It goes down. So x raised to minus 3 plus 1 is minus 2 upon minus 2. Done. Okay, because integration of x raised to n is x raised to n plus 1 by n plus 1. But here this part, what I will do to solve this, I will put, say, 1 by x cube is equal to, say, I will keep it as it is, say 1 by x to 4. It will be easy. Okay, I will put 1 by x cube is equal to t. So that means x raised to minus 3 is equal to t. Correct? So let's differentiate this. I am substituting everything in terms of t here. X raised to this will be differentiation of x raised to minus 3 is minus 3 x raised to minus 4 dx is equal to dt. So minus, that implies minus 3 upon x raised to 4 dx is equal to dt. Correct? Now see, I can replace 1 by x raised to 4. So that implies 1 by x raised to 4 dx is equal to minus 1 by 3 dt. 3 goes down. So that means this will be as it is, y cube minus y cube upon x square, 2x square as it is, minus, this will be now integration of, see, e raised to t, what is 1 by x⁴ dx? It's minus 1 by 3, so plus 1 by 3 dt is equal to c. And as you know, integration of e raised to t is e raised to t only, so that is minus y³ by 2x square plus 1 by 3 e raised to t is equal to c. But what is e raised to t? It's what is t? 1 by x³. So the solution is minus y³ by 2x³ plus 1 by 3 e raised to 1 by 3, sorry, e raised to t is 1 by x³ is equal to c. That's the solution. Tricky question. Okay, so practice the integration perfectly. So that's all. Fine. So this is the solution for this exact differential equation, reducible to exact form. dy by dx minus dx by dy equals x by y minus y by x. So this question, so solve for p. So as you know, p is nothing but dy by dx. So let's put p here. That is p minus, what is dx by dy? See, dy by dx is p. So dx by dy will be 1 by p equals x by y. Okay, I'll take x by y minus y by x. Fine. Now this is, take the LCM, p square minus p square minus 1 by p equals x by y minus y by x. So let's, usually the solution of p is obtained by converting to quadratic equation. So p square minus 1 is equal to p square minus 1 equals to p into x by y minus y by x. Or we can write this as p square minus p into x by y minus y by x minus 1 is equal to 0. Am I right? Fine. Therefore, this I can solve using quadratic equation, that is ax square plus bx plus c form. Now you see here ax to bx c form, the solution is x is equal to minus b plus or minus. The solution is what here? Right here. The solution is x is equal to minus b plus or minus root of b square minus 4ac by 2a. Fine. And if you see here, a is 1, because here I am taking the variable as x square as p here, p square, a is 1, so b will be minus, leave this p as it is, minus x by y minus y by x, and c will be minus 1. So the solution here will be, understanding like this, it will be very easy for you. So p is equal to minus b, see minus or minus plus, because solution is minus b plus or minus root of b square minus 4ac by 2a. So minus or minus become plus x by y minus y by x plus or minus root of b square. So b square, this minus become plus only, x by y minus y by x the whole square minus 4ac, 4a 1 into minus 1 is plus 4 divided by 2. Okay. So now the solution is, we are solving for p is equal to, because we have taken x square p is equal to minus b, so this will be x by y minus, because see minus b, no, minus minus plus minus y by x plus or minus root of b square minus x by y minus y by x the whole square is x by y minus y by x the whole square only, minus 4ac, a is 1, c is minus 1, so plus 4 whole divided by 2. So let's solve this here now. So this will be now p is equal to x by y minus y by x plus or minus root of, this will be x square by y square plus y square by x square minus 2ab. That means 2ab means a minus b the whole square, a square by b square minus 2ab, x y cancels, so minus 2 plus 4 upon 2, right? That means p will be now x by y minus y by x plus or minus this will be see x square by y square plus y square by x square plus 2, correct, upon 2, and this is definitely x by y minus y by x plus root of, see, x square by y square plus y square by x square plus 2 will be nothing but x plus y by x the whole square upon 2. That means P is equal to now x by y minus y by x plus or minus x by y, sorry, plus or minus plus y by x, because whole square root cancels upon 2. Upon 2. So this is what I have. Therefore, one value of P is x by y minus y by x plus x by y, I will take plus first, plus y by x upon 2. So that will be this and this cancels, 2x by y, so 2x by y, correct, no, x by y, x by 2x by y, 2 cancels, so one is P is equal to x by y. Similarly, the other value P is equal to x by y minus y by x minus x by y minus y by x upon 2. So this will be this and this cancels, this will be minus 2y by x, 2 cancels, so again P is equal to minus y by x. Now you know P is dy by dx, so dy by dx is equal to x by y, and here also dy by dx is equal to minus y by x. So let's separate the variables here. So from here we get x dx minus y dy is equal to 0. Am I right? X dx minus y dy is equal to 0. Okay, and the other one is this will become I will take this as dx by x, this minus go this side to become plus dy by y is equal to 0. So the solution here is integration of x dx minus integration of y dy is equal to, take it as say k. Okay, and our solution x square by 2 minus y square by 2, because integration x square by 2 y square by 2 is equal to k, or x square minus y square is equal to 2k. I will take this 2k as c only, okay, because 2k is 2k, 3k, what is constant, I will take it as say c. So one solution is x square minus y square is equal to c. The other one is, if you integrate this dx by x plus dy by y is equal to, I will take this as k only. So this will be log x plus log y is equal to k. I will take this as say log c, because log c is also constant, it will be easier for me, okay, to find a solution. K is also constant, log c is also constant. That means this will be now log x plus log y is log of x into y is equal to log c. That implies log cancels, x y is equal to c. So we have two solutions now. One is x square plus y square minus x square minus y square is equal to c, and other is x y is equal to c. Therefore, the total solution of the differential equation is nothing but just multiply it. So x square minus y square is equal to c means it will be, that implies the solution is x square minus y square minus c into xy minus c is equal to 0. This is the final solution for this question. That's all. This is how it is solved. Okay. See the question number from module 3, question number 5c is question number 5c. It says a rectangular box open at the top is to have volume 32 cubic feet. Find the dimensions of the box requiring least material for construction. least material for construction. Okay, so this is a classic example from Lagrange's multipliers to find the maximum meaning of two variables. So let's analyze this question. You see, for the Lagrange's method of multipliers, they need to give two values, that is a function and condition. Condition is something equal to, it's already given here. The condition is what? 32 equal to, volume is equal to 32. Now, if you analyze this question here, see a rectangular box open at the top. Okay, so let me draw a rectangular box like this. Okay, let me draw the box like this. So this is a rectangular box. Okay, now if you now for this rectangular box, I will take this as x, this as y, and this as z. Fine. For the box, as they say, this is open. This is what? Open. Open at the top. Okay. Now, see the condition is given here. Volume. For this, the volume will be x, y, z is equal to 32. This is what the condition. Okay. Now to find a function, what is function? Least material for constructions to construct the box and the full area. It is total surface area, that becomes a function here now. So the total surface area will be, see, total surface area or rectangular. Okay, this sum of this and this face. Correct? See, this is this first, this and the back face, x into y. So xy plus xy 2xy plus this and this two also, this one and this, y into z. So 2yz, but the top is open. See, xz, top is open. So it will be only xz. This becomes the equation. So I'll explain simple way this thing. So for solving the Lagrange's multipliers, the auxiliary function is equal to nothing but the function plus lambda into condition. Remember like this, it will be very easy for you to understand. Okay, so the function will be equal to the auxiliary equation f is equal to, what is the function here? It is 2xy plus 2yz plus xz plus lambda, and what is the condition? xyz is equal to, this is the condition. Okay, see, the condition is xyz is 32. There is no need to take 32 because anyway if you differentiate 32 it will be 0 only. Okay, so now this is the auxiliary function. So for the Lagrange's method of multiply, the first thing what we do, we find fx, that is partial differentiate with respect to x. Okay, so that will be equal to, what is fx here? 2y plus, fx is what? 2y, there is no x term 0, plus z plus lambda into yz. Okay, this is fx. Fine. So I'll write like this. What we do is we equate to so in the Lagrange's method of multipliers, what we do is first find the three derivatives fx, fy, fi, and equal to 0. Okay, so we write here first fx is equal to 0, means partial differentiation with respect to x. So this will be 2y plus 2yz 0 only plus z plus lambda into fx, right? So yz is equal to 0. Then fy is equal to 0, means partial differentiates with y. So 2x plus 2z plus lambda into fy, right? So x into z is equal to 0. And lastly fz is equal to 0. Means with 2xy 0, so 2y plus fz, right? X plus lambda into x y equals to 0. Now what we do, we equate everything in terms of lambda. Okay, so we have lambda yz equals minus 2y minus z. So lambda is equal to minus 2y minus z by yz. That will be equal to, see, take it this side, minus lambda yz is equal to minus 2y minus z. So lambda is equal to everything in terms of lambda, minus 2y minus z divided by z. So here y cancels, minus 2 by z minus 1 by y. Done. This is one value of lambda which we get from here. Z cancels. Similarly here also we can write lambda xz equals minus 2x minus 2z. So we have lambda equals to minus 2x minus 2z divided by xz. That will be x cancels, minus 2 by z minus again z cancels 2x. Similarly here also lambda xy is equal to minus 2y minus x. So lambda is equal to minus 2y minus x divided by xy. That will be minus 2 by x minus 1 by y. Fine. So I get this. So after equating with lambda, so what we simply do is we all are lambda, 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 correct? So you can equate it. So what we'll do, we'll equate this with this, then this with this. Let's see what happens. That means now if I equate all values lambda equal, right? So what I'll do, I'll equate this with this. So that implies now I'll equate this with this. So we can write minus implies minus 2 by z minus 1 by y equals minus 2 by z minus 2 by x. So here 2 by z cancels, minus minus cancels. We have x is equal to 2y. By equating, we find all values in terms of x, the simple method. Okay. So x will be as it is. All values we find in terms of x. So x is equal to y. So y is equal to how much? X by 2. That's it. Similarly, this and this. We equate this and this now. Okay. That is minus 2 by z minus 2 by x is equal to minus 2 by x minus 1 by y. So here again this cancels. We have 2 by z equals 1 by y. So we have z is equal to 2y. Okay. Now we have two important values here, y is equal to x by 2 and z is equal to 2y. That is again 2 into what is y? Y is x by 2, that is equal to x only. So z is equal to what? X. Am I right? Z is equal to y, so y is equal to x by 2. Okay, z is equal to x. That's it. Therefore, what we do, we put in the condition. The condition is, so by equating all fx, fy, fz is equal to 0, we find all the values of x, everything y and z in terms of x as it is. See, the condition is x, y, z is equal to 32. So I told x as it is. What is y? X by 2. And what is z? X is equal to 32. Implies x cube is equal to 64. So x is equal to 4. From this we can find all the values. So when x is equal to 4, what is y is equal to? 4 by 2, because y is x by 2. So 2. And z is equal to what? 4 only. That's all. So these are all the values now which we are obtained. Okay. Now from these values we will give the extreme values or the maximum minima. So what asking, find the dimension of blocks required least material for construction. Therefore total surface area is equal to, put here, 2 into x, 2 into what is x? 4. Y? 2 plus 2 into yz plus 2 into 4 plus xz 4 into 4. That is 416 plus 16 plus 16, that is equal to 48. So total surface area is 48. Therefore you can write, find the dimension of the box requiring least material for the construction. So this is 48. So by Lagrange's multipliers, so total surface area with this value is equal to 48. So find the dimension of box required to requiring least material for construction. So this is the total surface area, that is square feet we get. And the dimension of the box are, therefore right, therefore dimension of box requiring least material for construction are x is equal to 4, y is equal to 2 and z is equal to 4. That's it. So with this dimension, the least area found is 48 square feet. That's all. This is how it is done. A very important question, but you need to practice. The same question they may repeat in the examination. So please practice it. See, the next problem here is question number 6a. Solve dy by dx plus y cos y cos x plus sin y plus y by sin x plus x cos y plus is 0. A question from exact differential equation. I already solved it. So please refer the file question here. Find the link in the description below. The question 6b is solve or show that the family of parabolas y square is equal to 4a into x plus a is self-orthogonal. Okay. From question from orthogonal trajectories of Cartesian curves. Okay, so what we do, first we differentiate to remove a. If you differentiate, we get 2y into y1 or dy by dx, it is y1 is equal to, it's 4a, correct. So we are not able to eliminate a. So what I will do here is, what I will do simply first say, I will write the question here, okay, best to solve is, okay. I write it here. So y square is equal to 4a into x plus a. Let me take this as 1. Fine. Now here, when I differentiate this, I get 2y into dy by dx, that is y1 is equal to 4a, correct? Differential x is 1. But I am not able to eliminate the a here. So what I will do here, that implies a is equal to 2y y1 divided by 4. That is y1 by 2. Fine. Now this value of a, I will put in the question. So put a in 1. So y square is equal to 4 into y1 by 2 into x plus a, that is equal to 2y y1. Okay, oh sorry, again this will be what? Forgot here. So into 4a is y1 by 2 plus x plus y1 by 2, and that will be equal to 2y y1 into else if you take here, it will be y1 by 2, right? So x plus y1 by 2. Fine. Am I right? Okay. Now let's open the bracket. So y square is equal to 2xy y1 plus 2 cancels plus y into it will be, so multiply here, 2 cancels, it will be y square into y1 square. Fine. Now see, I can remove y from both sides. That implies y is equal to 2x y1 plus y into y1 square. This is what we have now. Okay. Now we can, to find the orthogonal trajectory for Cartesian curve, what is the condition, what is the process? We, after removing the constant a, whatever constant given, we replace dy by dx by minus dx by dy. So right here, so replace dy, I will take this as second, okay, this is second. So replace dy by dx by minus dx by dy. That means I taken y1 here, no? So here y1 is equal to dy by dx, right? Okay. That means, that implies y1 is equal to minus 1 by y1. Oh sorry, yeah, y1 is minus 1 by 1. So put it here now. That implies, so y is equal to 2x into minus 1 by y1, right? Plus y into minus 1 by y1 square is 1 by y1 square as it is. Okay, am I right? So y is equal to 2x into, in place of y and put minus 1 by 1, and we have y into y1 square. So this will be now again minus 2x by y1 plus y by y1 square, correct? Now let's take the LCM of it. So we have y is equal to minus 2x plus there is y1 square. Okay, 2x LCM is y1 square. Fine, LCM is y1 square. So this will be 2x y1 plus y. Okay. Now what you can do is, that implies y into y1 square is equal to minus 2xy1 plus y, and that implies y is equal to, what is y, tell me? Y is equal to, take it this side, so 2xy1 plus y into y1 square, that's it. Am I right? So y is equal to 2xy1 plus y into y1 square. Now I take this as say 3. Now see, we got a differential equation in 2s, y is equal to 2xy1 plus y1 square. For that, to find the orthogonal trajectories, we replace dy by dx with minus by applying process here, minus 1 by or minus dx by dy or minus 1 by 1. When we apply it, we get the same equation. See both. So both 2 and 3 are same. Therefore, we can write the parabola y square is equal to 4a into x plus a is self orthogonal. That's it. This is how it's done. Okay. The next problem here is now the question number 6c. Question 6c, very important question. They frequently ask this in examination. Many times they ask. Solve the equation that is px minus y into py plus x equals 2p by reducing to Clade's form, and you are using a substitutions here. U is equal to x square and v is equal to y square. Okay, so they again use x square, using y square. So what we do first? We have to write everything in terms of u and y and solve. Make it to Clade's form. Okay, so du by dx will be now 2x here and dv by dy will be 2y. Fine. So my small p is nothing but I have to write small p in terms of u and v. So small p is dy by dx. Now dy by dx as a chain rule in terms of u and v can be written as dy by dv into dv by du into du by dx. See, this term dv cancel and what dv cancel, du dy by dx remains. But we get in form of u and v. That is nothing but again see what is dy by dv. See, dv by dy is 2y. That is 1 upon 2y. What I'll do, this dv by du, the factors for substitution, I will take this as capital P into this again 2x. That will be 2 cancels. We will get this as p into x by y. So therefore, small p is equal to capital P into x by y, small x by small y. That implies small p is equal to capital P into, what is x? U is equal to x square. Fine. So u is equal to x square means what is x? X is equal to root of u divided by y, root of v. See, I have got in terms of u and v now. So let's put this in place of small p. We'll put this here. Where p is that put? So it implies now we can write p, right? P is capital P into root of u by root of v into x. See here, into x. Again, what is x? So I'll write here better. That implies x is equal to root of v and y is equal to root of v. Okay, better. Fine. So p into, what is p? Capital P root u by root u by root v. X is root u minus y is root v into bracket again. P is root u by capital P root u by root v into y is root v plus root u, because x is root u, equals 2 into p into root u by root v. Now here take the LCM. See, u into u is u, so p into u minus, take the LCM, root v, small v upon root v into, see this v and v cancels. See what remains, p root u plus root u. So root u is common here into capital P plus 1 is equal to 2p root u by root v. Again here compare both, is multiplied, so u, v cancels. So we have capital P into u minus v into p plus 1 equals 2p. Fine. That implies now we can write pu minus v is equal to 2p by p plus 1. Fine. So again I can write this equation in v form as is because v is basically y, uv. So v form as nothing but we can rewrite this v form as pu, capital Pu minus 2p by p plus 1. Now this is all capital, okay, p capital. Now this is what? Clariots. This is Clariots. And the Clariots equation, general form is y is equal to px plus f of p. And the solution for Clariots is y is equal to cx plus f of c. That means when you identify it as Clariots, px plus f of p, function f of p, what we do is you simply replace in place of p put c. That's all. So here therefore this is Clariots. So this becomes Clariots equation now. This is Clariots. So once it is Clariots, so what we do? The solution is v is equal to pu p c. What solution? In place of p put c. So it will be what? I take capital Cu, c into u, okay, minus 2c by c plus 1. So I will write in the standard form because here they are given v as y square and u as x square. So the solution here will be now for Clariots v. What is v? Y square is equal to c into x square minus 2c by c plus 1. That's the general solution for this question. Okay, a very important question. So please practice it 3 to 4 times so that you will be able to write in the examination. So very important. Okay, they may repeat the same question this time as it has been repeated many times in the previous exam papers. The next one is okay. So we done it module 3, last part. Now the module 4, that is higher order differential equations. So let's start with the module 4 now. So module 4, question number 7a. Solve it says okay, d³ by dx³ plus 2d² by dx² plus dy by dx equals e raised to minus x plus sine of 2x. So first let's find the CF here. So first it will be d³ plus 2d² plus d into y equals e raised to minus x plus sine 2x, right? So this will be now m³ plus 2m² plus m is equal to 0. You can do directly or you can use your calculator. I think here m is common, so m² plus 2m plus 1 is equal to 0. So there totally m³ is 3 roots, okay. So one value is m is equal to 0 and m² plus 2m plus 1 is m plus 1 the whole square is equal to 0. That implies the roots are m is equal to 0, minus 1, minus 1, underline. Okay, so we have found the roots here, one is 0 and m² plus m plus 1, okay, minus 1, minus 1. So the CF will be now C1 e raised to 0x, C1 only, plus C minus roots are same. When roots are repeated, the CF is C2 plus C2x into e raised to minus x. Now this is my completive factor, please underline it. Okay, now the next is find the PI. So PI, we have yp is equal to e raised to minus x plus sine 2x divided by d³ plus 2d² plus t. And as I told you always, please when the right side is plus or minus, separate it. So e raised to minus x by d³ plus 2d² plus d plus sine 2x by d³ plus 2d² plus t. Fine. So we have identified both the types here. So one is type 1, other is type 2. So in type 1, e raised to x upon f of d, here you see e raised to x, 1x. So a is 1. So replace d by what? Minus 1. And here in type 2, you can check my previous videos also. we replace the denominator only d square, don't touch the d's. So d square by minus a square, minus what is a? 2, 2 square, minus 2 square is 4. So only d square, okay. So that means what you can do here, see here, don't get confused, there is given d cube here, so you can write d cube as d into d square, that's all. Fine. Therefore now the solution is yp is equal to e raised to minus x by, replace d by minus 1, so minus 1 plus 2 minus 1, correct, and because minus 1 square plus 2 minus 1, yeah, and plus sine 2x by this is d square, d cube is minus 4d plus 2 into d square plus 2 into minus 8, am I right? Correct. So it is see d cube, right? So d cube is d square dt, so d square is minus 4d. In place of d square put minus 4, so minus 4 means okay, minus 4 plus d. Fine. Now this will be again yp is equal to, see minus 1 minus 1 minus 2 plus 2 0. So in any differential equation solution, when the denominator is 0, multiply numerator by x and differentiate denominator. So here differentiate d cube is 3d square plus 4d plus 1. Fine. And here this will be sine 2x divided by, see minus 4d plus d is minus 3d minus 16. Okay. Now again replace here d by minus 1. So this will be now x e raised to minus x divided by 3 minus 4 plus 1, correct. 3, you replace d square minus d by minus 1, so minus 1 square is plus 1, 4 into minus 1 minus 4 plus 1. And here what I can do here is, see as we discussed in many problems previously, in type 2 if the denominator is not d, there is d plus something, we rationalize, because we in compulsory for type 2 the denominator should be d square, there should be a d square term compulsory, for that we rationalize. So but for rationalizing the first term should be plus, so what I simply do here, see plus, I write this as sine 2x divided by, I take minus outside, 3d plus 16, fine. Correct, no? That means the rationalizing factor is 3d minus 16 divided by 3d minus 16. So again see here this will be 0 again, correct. Again if the denominator is 0, multiply numerator by x, x square into e raised to minus x upon, again differentiate denominator, differentiate 3d square is 6d minus plus 4, correct. 2 to 60 plus 4, yeah, done. Again replace d by minus 1 here, and for this it will be now 3d sine 2x minus 16 sine 2x whole divided by minus 9d square minus, what is 16 square? What is 16 square? 16 square is 256. Are you getting it? A plus b, a minus b, a square minus b square, 9d square minus 16 square. Again replace d square by here minus 4. Fine. So the final solution here will be, so particular integral yp will be x square e raised to minus x divided by 6 minus 6 plus 4 2, correct. In place of d put minus 1 minus x minus 6 plus 4 2, solve, and this will be minus okay, this plus by minus minus 3d sine into d means differentiate, into d means differentiate, into d, so d sine 2x, differentiate sine 2x is 2 cos 2x, so 6 cos 2x minus 16 sin 2x as it is upon, again 9d square minus 256 will be in place of d square put minus 4. So let's see what is the result here. So 9 into 16, right. So 9 into 16 minus 256, am I right? 9 into, replace d square by minus 4, sorry, replace d square by minus 4, right. So 9 into minus 4 is minus 36, in place of d square put minus 4 minus 256, and that is minus 292. So what I'll do, minus 292 means this will become minus, so this will become plus 292, that's all. Okay, therefore solution is y is equal to cf plus pi. What's cf now? Cf is that's c1 plus c2 plus this is sorry c3, yeah, c3, c1 plus c2 plus c3x this into e raised to minus x square e raised to minus x by 2, and let's check how much it is. 6 cos 6 by divided by 292. Let's simplify it. So 3 by 146 plus 3 cos 2x by 146 minus 16 by 292. 16 divided by 292. 4 by 73 minus 4 by 73 sin 2x. That's the final solution. So y is equal to what? Complementary factor plus the particular integral. This is the solution. What you get? Please verify. Fine. So we are done with this question. Now let's move to the next, that is question number 7b. So the question 7b is solve by variation of parameters, that is d square y by dx square plus y equals 1 by 1 plus sin x. Okay, so let's solve this now. Now variation parameters. So first we find CF here. So d square plus 1 into y is equal to 1 by 1 plus sin x. So m is equal to, see, m square is equal to minus 1. So m is equal to plus or minus I. So the complementary factor will be c1 cos of x plus c2 sin of x. Very important. If you go wrong in the CF in variation parameters, you will not get marks. They will cut the marks. Okay, because the whole solution depends on CF here. So the solution can be written here as y is equal to a y1 plus b y2. Fine. So here y1 is cos x and y2 is sin x. Okay. From this we will find something called as Wronskian. W is equal to y1 y2 dash minus y2 y1 dash, that is equal to, what is y1? Cos x into again cos x, differential sin is cos x, minus sin x into again differential cos x is minus sin x. So that is cos square plus sin square x. That is equal to 1. So we have W is equal to 1. Underline it. Okay, you get marks here. Now the formula for A is minus y2 into phi of x upon w dx. So that is A is equal to minus, what is y2? y2 is sin x. So what is phi of x? Phi of x is 1 by 1 plus sin x. Okay, into dx. Fine, because upon w is 1. So we need to integrate this. So how shall we integrate this? To integrate this, what I'll simply do, I rationalize it. Okay, minus sin x upon 1 plus sin x. Because I cannot substitute also, so rationalize. So it is 1 minus sin x divided by 1 minus sin x dx. That will be now A is equal to minus integration of sin x minus sin square x dx divided by, see, I write directly here, 1 plus sin x 1 minus sin x is 1 minus sin square x. And what is 1 minus sin square x? Cos square x, correct? So cos square x. See, open a bracket, sin x minus sin square x upon 1 plus sin into 1 minus sin, a plus b, a square minus b square. So 1 minus sin square is cos square x. Now this separates to be minus integration of, let's separate this, see, sin x upon cos square x. Sin by cos is tan. Okay, so that is, and it again remains 1 by cos. What is 1 by cos? Secant. Okay, so I write this as sin by cos is tan x into, I write like this, okay, tan x by cos x. Fine. Next, then minus and minus plus integration of sin square by cos square is tan square x. Okay, now again I can rewrite this as A is equal to minus integration of tan x by cos x is 1 by cos x secant x into tan x dx. And how do we integrate tan x square x? See, tan square x is what? 1 plus tan square is secant square, so tan square is always taken as secant square plus 1 because the standard integration of secant square x is tan x. So we have secant square x minus 1 dx. Okay, so the integration for this will be a is equal to minus secant x because differentiation of secant x is secant x tan x, so integration of secant x tan x is secant x, and plus integration of secant square x what? Tan x minus x plus I'll take constant, say k1, constant of integration, because integration of secant square is what? Tan. See, derivative of tan x is secant square, integration ulta, integration of secant square tan, and integration 1 is x always. Now let's find b here. So b is equal to, again formula is y1 into phi of x upon w dx, that is b is equal to, now what is y1 here? Cos x upon 1 plus sin x, and I think this is a very simple integration because differentiation of sin is cos, so I can put 1 plus sin x is equal to t, so it implies cos x dx is equal to dt, so it will be integration of dt divided by t, and that is log of t, that is b is equal to log of, what is t? T is 1 plus sin x plus constant k2. Okay, therefore the solution is y is equal to a y plus b by 2. So the solution for this is y is equal to, what is a? Minus secant x plus tan x minus x plus k1 into cos x plus b by 2. b is log of 1 plus sin x plus k2 into what is that? y2 sin x. That's all. That's the solution. Again, important problem which can be repeated in the examination. That's how it's done. Okay, and also please do follow the videos on my channel. Those problems that solved on variation of parameters are also very important. They can also be asked in examination, like d square plus 1 into y is equal to tan x and so on. And also please do refer the Facebook and Instagram page also, where I have mentioned some important questions on higher differential equation. And one more time request all of you, once you finish the exam, please do forward me the question paper on my WhatsApp number or email me. So the link and the number and link, the email ID is given in description below. Okay, so now as we are done with this module, it is 7b. Let's move on to the next question. The next one is question 7c. Solve x square y double dash plus x into y dash plus y is equal to 2 cos square log x. A question from Cauchy's differential equation. This problem I solved it, so please find the link in the description below. Or next one is 8a. So let's solve this question here. So question 8a, it says solve d square y by dx square minus 4y equals 3 raised to x plus cos hyperbolic 2x minus 1. Okay, standard question from differential equation. This question has also been repeated many times in examination. Fine. So this, okay, so first it is d square minus 4 into y equals 3 raised to x plus cos hyperbolic 2x minus 1. Now m square minus 4 is equal to 0, so m is equal to plus or minus 2. That is m has two roots, because we need to find the roots here. So auxiliary equation is m square minus 4 is equal to 0, so m is equal to plus or minus 2, so write it plus 2 and minus 2. So both different roots, so the complementary factor is c1 e raised to 2x plus c2 e raised to minus 2x. As I always keep on reminding you, please underline the complementary factor. Now to find a particular integral, we have yp is equal to 3 raised to x upon d square minus 4 plus cos hyperbolic 2x minus 1 upon d square minus 4. Now okay, it was basically okay, 3 raised to x, I write first 3 raised to x plus cos hyperbolic 2x minus 1 by d square minus 4, And as I always keep on telling you, when the numerator is plus or minus sign, always separate. So this will be now 3 raised to x upon d square minus 4 plus cos hyperbolic 2x minus 1 upon d square minus 4. Now, see, that implies yp is equal to, see, 3 raised to x can be converted to exponential form, that is a raised to x is equal to e raised to log of a into x. So you can write 3 raised to x as e raised to log 3 into x, that is e raised to x form, upon d square minus 4. And again cos hyperbolic is also a type 1 exponential function. See, only cos and sine are trigonometric. Type 2, cos hyperbolic 2x minus 1 is an exponential function, because the formula for cos hyperbolic x is e raised to x plus e raised to minus ax by 2. Remember it. So this will be now again e raised to 2x minus 1 upon 2 into d square minus 4. Why? Because cos hyperbolic x is e raised to x plus e raised to minus x by 2. So cos hyperbolic 2x minus 1 is e raised to 2x minus 1 plus e raised to minus 2x minus 1 divided by 2. So 2 into d square minus 4. Now as you see, it's all type number 1. So e raised to ax, here a is log 3. So replace d by log 3 as in type 1. We replace in the denominator all d's by a. Here a is 2, so replace d by 2, and here minus 2. Am I right? Minus 2x, no? So minus 2. Okay. Fine. Now let's replace it. We get e raised to log 3x divided by log 3 whole square minus 4 plus this will be e raised to 2x minus 1 by 2 into 4 minus 4 plus e raised to minus 2x plus 1 by 2 into 4 minus 4, and obviously this is 0, this is 0. So when the denominator is 0, we multiply, this will be as it is, e raised to log 3x divided by log 3 square minus 4. But here if the denominator is 0, then we multiply numerator by x upon differentiate denominator. So 2 into, don't forget it's 2, differentiate d square is 2d. Okay, differentiate d square is what? 2d. Again plus, again since denominator 0, x into e raised to minus 2 plus 1, or you can write you can write as it is, plus minus 1. Okay, fine, upon 2 into, again derivative of d square is 2d. So again here this is over, so we replace d by 2 and here d by minus 2. So the particular integral yp is equal to now e raised to log of 3 x by log 3 whole square minus 4 plus x e raised to 2x minus 1 by, see, replace d by 2, 2 to the 4, 4 to the 8, and here plus x e raised to minus 2x minus 1 upon 2 into minus 2 minus 4 minus 8. So this will be minus. So solution is, as you know, cf plus pi, so y is equal to c1 e raised to 2x plus c2 e raised to minus 2x plus e raised to log 3x divided by log 3 whole square minus 4. Okay, keep it as it is, plus x e raised to 2x minus 1 by 8 minus x e raised to minus 2x minus 1 by 8. That's all. So this is solution. Okay, that's it. Important question, to practice it. Fine, we'll move to the next question. Please practice this question. It can be asked in examination, as I told you. I am again sorry for the delay in uploading paper, but anyway, 3 to 4 hours if you spend on a paper practice is more than enough. Fine. And of course, the last minute study is the best study. It will fetch you more marks. Okay. The next one is question 8b. Question 8b. Okay. Is solve 3x plus 2 the whole square d square y by dx square plus 5 into 3 plus 2x dy by dx plus y equals 4x. Example from Legendre differential equation, ax plus b the whole square plus 2x. No, It is, this is 3 plus 2x. 3 plus 2x. Now this is Legendre's, that is of the form of ax plus b. So ax plus b the whole square y double dash plus again ax plus b into y dash plus y equals phi of x. As you see clearly, a is 1 here, ax, see x1. Okay, so in Legendre's what you do, first we put log of whatever 3 plus 2x is equal to t. That implies 3 plus 2x is equal to e raised to t. But here you see we need x here. Again implies therefore x is equal to e raised to t minus 3 divided by 2. Am I right? Simple equation. 2x is e raised to t minus 3, so x is by 2. Now the Legendre differential equation, in that again please do follow the previous videos on theory of Legendre's equation. You will have a deep and better understanding of the concept. So ax plus b whole square y double dash is written as a square into, so what is a here? 2x. A square into d whole square y double dash means d minus 1 into y. A square 4d into d minus 1 into y plus 5 into again a plus b, ax plus b, y dash is a into dy. So a is 2 here, again 2 into dy plus y is equal to 4x. What is x? E raised to t minus 3 by 2. As always in Legendre's and Cauchy's, the right side we replace everything in terms of t. Now this will be 4d square minus 4d plus 10d plus 1 into y equals 2 e raised to, because 2 and the 2 2s are 2 e raised to t minus 6. Fine. Correct. So 4d square minus 4d plus 10d. So this is what we have here. Fine. Now let's again simplify this. This will be 4d square plus 6d plus 1 into y equals 2 e raised to t minus 6. Okay, so 4d square, am I right? The calculation, please check it. 4 into d minus 1 plus 5 into 2. Yeah, perfect. 10. Okay, plus 10. 10 minus 4 is 60. Okay. So now 4m square plus 6m plus 1 is equal to 0. The auxiliary equation. From here we find the roots here. So better I use the calculator. In the calculator we put mod on. Okay, mod equation 5. So it's polynomial, right? Second order 3. We have 4, 6, 7. 4 is equal to 6 equals to 1. Sorry, 1 equal to. We get minus 3 plus or minus. So we get m is equal to, now roots as minus 3 plus root 5 by 4 and minus 3 minus root. See, there is no ion all here. Okay, people mistake this for ion all. Okay, this is plain numeric. So that's why the CF is C1 e raised to minus 3 plus root 5 by 4 x plus C2 e raised to minus 3 minus root 5 by 4 x. This is my CF. Again, as I tell you, in Legendre's Cauchy, the right side you are taking as t, therefore it will not x, it will be t. Later in the answer you will replace by x. Okay, fine. So we have CF here, so yp is equal to now 2 e raised to t minus 6 by 4d square plus 6d plus 1. That is again what? So it will be 2 e raised to t by 4d square plus 6d plus 1 minus 6 divided by 4d square plus 6d plus 1. As when the numerator is constant is type 1, or we can write it as e raised to 0x, because e raised to 0x is 1. So replace d by 0 here, and here type 1 replace d by 1. So the particular integral yp becomes 2 e raised to t by, in place of d put 4, d put 1, 4 plus 6, 10 and 11. And here minus 6 by, in place of d put 0, it will be 1. That's all. Therefore solution is equal to CF plus PI. So C1 e raised to minus 3 plus root 5 by 4 t plus C2 e raised to minus 3 minus root 5 by 4 t plus 2 e raised to t by 11 minus 6. Therefore, as I discussed earlier, since the question we have taken the assigned ht and solved the equation, made it converted to differential equation and we solved it. So since the question is given in terms of x, so solution also need to be in terms of x only. So choose appropriately. What is t here? T is log 3 plus 2x. So c1 e raised to minus 3 plus root 5 by 4 into what is t? Log 3 plus 2x. Log 3 plus 2x plus c2 e raised to again minus 3 minus root 5 by 4 into 2x plus 2 e raised to t. What is e raised to t? It's 3 plus 2x. Because everything you need to write in terms of x only. So e raised to t is what? 2 into e raised to is 3 plus 2x. 2 into 3 plus 2x divided by 11 minus 6. That's the solution. Okay. So that's all. We have it. Underline the solution. So that's how it is done. Legendre differential equation. So please refer the model question papers B, that is 1BMATE101 also. In that also I solve some problems on Legendres and Cauchys. Okay. Now moving to the next problem is one more problem, that is question 8c, solve by variation of parameter. See, the question number 8c here is solve by variation of parameters. Question 8c, solve by variation of parameters. It says d square y by dx square plus dy by dx minus 2y equals 1 by 1 minus e raised to x. Okay, right, okay, fine. So again d square plus d minus 2 into y equals 1 by 1 minus e raised to x. As we solved previous problems on variation parameters also, roots are very important. So let's find the roots here. M square plus m minus 2 is equal to 0. If roots are wrong and the CF is wrong, then the whole solution will be 0. We have mod 1. So let's go to equation again. Square, no? Yeah, 3. Fine. So let me verify the question one more time. It's d square y by dx square plus dy by dx minus 2y is equal to 1 upon 1 minus e raised to x. Fine. So if you find the CF here, 1 equals minus 2 equals. So we have 1 and minus 2. Okay. So we have the roots as 1 and minus 2. So the roots are 1 and minus 2. So m is equal to 1 comma minus 2. So the complementary factor will be c1 e raised to x plus c2 e raised to minus 2x. Now from the CF, if write the solution as y is equal to ay1 plus by2. That means here y1 is e raised to x and y2 is e raised to minus 2x. Now we need to find a very special term called as Wronskian w. So w is equal to y1 y2 dash minus y2 y1 dash, that is equal to e raised to x into, see, y2 dash differential e raised to minus 2x is e raised to minus 2x into minus 2 minus e raised to minus 2x as it is, differential e raised to x e raised to x only. So w is equal to minus 2 e raised to x, e raised to a, e raised to b is e raised to a plus b. So x minus 2x is e raised to minus x and minus e raised to again minus x, that is minus 3 e raised to minus x, that is w. Underline. So we have the w here. Fine. Okay. Now w is 3 minus 3 e raised to minus x. Therefore a will be minus, formula is phi of x into y2 divided by w dx. Simplest way of solving it. So what is phi of x? 1 upon 1 minus e raised to x into what is your, okay, bracket I'll put. What is y2? Y2 was e raised to minus 2x. E raised to minus 2x upon w. What is w? Minus 3 e raised to minus x dx. Fine. So this is what we have now. Okay. Now minus and minus will cancel. Okay. when it cancels, this will be a is equal to minus cancels, so becomes, I can take 1 by 3 outside, integration of, see 1 by 3 outside, and denominator will be as it is 1 minus e raised to x. But here see e raised to minus 2x and e raised to minus 2x, this e raised to minus x will go top to become, see it's divide, okay, e raised to minus 2x plus x, e raised to minus x, so e raised to minus x is nothing but 1 upon e raised to x. That's fine. So this is what we get here. Now wherever exponential is involved while integrating, the simple rule is to put e raised to x is equal to t. Okay, so when I put e raised to x is equal to t here, we have to solve this integration. We have e raised to x dx is equal to dt. It implies dx is equal to how much? 1 by e raised to x dt. That is dx will be equal to, what is e raised to x? T, 1 by t dt. Okay. So for this I will write here the integration. See what I do, wherever, remember one more time, wherever in integration e raised to x is involved, so what to do? I hope you got this now. E raised to minus 2x upon e raised to minus x. So minus x should go top, minus x plus x minus x. So e raised to minus x in the numerator goes down to become e raised to x. So then what I put? I put e raised to x is equal to t to solve the integration. Differentiate e raised to x dx is equal to dt. So dx I want here. This dx will be 1 by e raised to dt, but e raised to x is t. So dx is 1 by t dt. So we write here a is equal to 1 by 3 integration of dx is 1 by t dt, correct. And again, fine, again see 1 minus e raised to x is 1 minus t, again dx is 1 by t dt, 1 minus e raised to x is t as you know, and there is one more e raised to x, that is again t only. So this becomes what? Into t, into t dt. So this becomes a is equal to 1 by 3 dt by t square into 1 minus t. Okay, now we need to solve this integration. So how do we solve this integration? So we solve this by using integration of parts. So I'll write here 1 upon t square into 1 minus t is equal to a upon t. See 1 upon, if it is 1 upon t square means we write as a upon t plus b upon t square plus c upon 1 minus t. Then take the LCM. So 1 is equal to a into, LCM is t square into 1 minus t. So a into, there is t square required, t into 1 minus t plus b into 1 minus t plus c into t square. Okay. So next we put t is equal to 1 here, because see 1 minus t, what makes it 0? 1 is 1 value, 1 minus 1 0. So we have implies 1 is equal to, and I put t is equal to 1, this 0, c is equal to 1. Then I put t is equal to 0. If I put t is equal to 0, I get 1 is equal to 0 and 0, t 0, b is also equal to 1. So lastly what we can do is we can compare the coefficients. So if we compare coefficient of t square, then 0 is equal to, see a t t square. See what I get? A t minus t square. No. So 0, if you compare the coefficients of t square, then a t minus a t square is minus a, and here coefficient of t square is plus c. Okay, it implies I got c, a is equal to c, that is equal to 1. Therefore this integration will be nothing but a is equal to, okay, the integration of c 1 by 3. Okay, so I'll find the integration. Therefore dt by t square plus t is written like this, right? Therefore I will write like, okay, therefore solution is a is equal to 1 by 3 integration of this whole thing is much. So a is 1 by t plus b is 1 by t square, c is again 1 by 1 minus t into dt, correct? So that is a is equal to, now capital A is 1 by 3, integration of 1 by t is log t, integration of 1 by t square is minus 1 by t, because differentiation of, as I tell you, very important integration, differentiation of 1 by x is 1 by x minus 1 by x square, so integration of 1 by x square is minus 1 by x. So this also plus log of 1 minus t, okay, plus k1. So I found here a value. Next let's find b. So b will be similarly integration of phi of x into y1 dx divided by w. So now b will be integration of, see what is phi of x? It is 1 upon 1 minus e raised to x, and y1 is e raised to x dx divided by w is minus 3 e raised to minus x. Fine. Okay, again this will be integration of, see I can take minus 1 by 3 outside, take constant outside always first, minus 1 by 3 and e raised to x dx divided by 1 minus e raised to x into e raised to minus x. Okay, I think again this will become minus 1 by 3 outside, integration of, see e raised to x upon e raised to minus x, or I can bring it down also, okay, or I can take it up, you wish. So e raised to x, take it up, so it will be e raised to 2x dx divided by 1 minus e raised to x, right? Okay, so this will be now e raised to x upon e raised to minus x is x goes to up plus x to x. Okay, now again here I put e raised to x is equal to t. So I get same thing, we get that implies we get dx is equal to, so same thing here we write, so dx is equal to 1 by t dt. Now let's solve this. So b is equal to here minus 1 by 3 integration of e raised to x means it is a t, so e raised to 2x says it is t square and dx is 1 by t square dt 1 by t dt, correct. E raised to 2x is e raised to x is t, so e raised to 2x is t square and dx is 1 by t dt and 1 minus t. Okay, so this will be now minus 1 by 3 tt cancels t dt by 1 minus t. Fine, tt cancels. So how do I solve this again now? So to solve this integration, what I can do is I will take minus inside, so this will become 1 by 3 integration of t dt by t minus 1. Okay, now what I can do, I can rewrite this as 1 by 3, see t minus 1 is there in denominator, no. So what I will do, see what I did, I took minus inside, so this minus will take inside, no? So t upon minus plus t minus 1. So this t I will write it as t minus 1 plus 1, now it makes sense. Okay, so that will be now 1 by 3, simple steps of integration, again separated, t minus 1 by t minus 1 is 1 plus 1 by 3, okay, dt plus 1 by 3 integration of 1 by t minus 1 dt, and that will be 1 by 3 t plus 1 by 3. So integration of 1 by t minus 1 is log t minus 1 plus k2. Okay, so here a will solution is, because t is nothing but e raised to, I have taken e raised to x, so 1 by 3 log of e raised to x minus 1 by e raised to x plus log 1 minus e raised to x plus k1, and b will be 1 by 3 e raised to x plus 1 by 3 log of e raised to x minus 1 plus k2. Therefore, solution is y is equal to a y1 plus b by 2. What is a? A is, okay, found to be 1 by 3 log e raised to x minus 1 upon e raised to x log of 1 minus e raised to x plus k1 into e raised to x plus 1 by 3 e raised to x plus 1 by 3 log of e raised to x minus 1 plus k2 into this e raised to minus x. Yeah, that's the solution, a lengthy solution. Okay, so they have asked this question in the model question paper. So usually in VTU I have seen that they won't ask such difficult question, the question is very easy. But since it was as a request to solve the model question paper, I solved this question. But my suggestion is to please refer the other videos which I have solved in my playlist and courses, and also please refer the previous other branch question paper, that is especially 1BMATC101. There also discuss 2 questions on this variation parameters. Please check those questions. Okay, fine. So this is the solution by variation parameters. So now let's move to the next question. Now the next module is module 5. It's your favorite module. So many engineering students love this. See, in this module you can score the full 20 marks, I tell you. So only follow my advice. First thing, solve the problems which are solved on my channel, the courses and playlist. Second thing, this module is common for all, 1BMATS101, 1BMATE101 and 1BMATC101. Solve all those questions. That's enough. If you do that, you can easily score 20 marks. Okay. So fine. The first question is, and also one more time, after your exams, please do forward your papers. That will be helpful. So first question is module 5. Find the rank of the matrix by reducing to row echelon form. So this problem is important. I solved it already. So you can find a link in the description below. The second is question 9b, solved by Gauss iteration method. See, as I told you, similar problems now I solved for the other schemes also. Please refer those questions because the process remains same. As this is a Gauss iteration method, because the 20 is greater than 1 minus 2 and 20 in the second, 3x plus 20y minus z. Here also 20 is greater than 3 minus 1, and the last also. Okay, so you can easily apply the Gauss method because the elements along the principal diagonals are greater than other elements. Anyway, as I given the solution, please check it out. Fine. The next question C is also find a dominant eigenvalue eigenvector for corresponding matrix by Rayleigh's form method. Like these questions also I solved in my notes in my YouTube channel, the videos and other previous 1BMATC101 and 1BMATS101. Please refer that. For your reference, I will give the solution here. Okay. So next one is question number 10b. Last one. Investigate the values of lambda and mu for the equation 2x plus 3y plus 5z is equal to 9, 7x plus 3y minus z is equal to 8, and 2x plus 3y plus lambda z is equal to mu have no solution, unique solution and infinite solution. So question number 10a. So we have the system of equations here. 2x plus 3y plus 5z is equal to 9. Okay, and 7x plus 3y minus z is equal to 2z is equal to 8, and 2x plus 3y plus lambda z is equal to mu. Verified. 2x plus 3y plus 5z is equal to 9, 7x plus 3y minus 2z is equal to 8, 2x plus 3y plus lambda z is equal to mu may have no solution, unique solution and infinite solution. Very important question. Like this, one more questions I have solved for 1BMATS101. That is very important. Please check that. So we have here first A argument B equals 2, 3, 5, 9, 7, 3 minus 2, 8 and 2, 3 lambda mu. So the concept of echelon form is we make this, making use of this 2, we make below all 0. So this is simple. You can write this as R3 minus R1 because I can make directly 2 minus 2 0. Okay. So we have A argument B equals 2, 3, 5, 9, 7, 3 minus 2, 8, 2 minus 2 0, 3 minus 3 0, and this will be lambda minus 5 and mu minus 9. Done. Now you need to make 7 0 making use of 2. So LCM is 14, multiply by 7 and multiply by 2. 2 7s are 14, 2 3s are 6, 2 2s are 4, 2 is are 16, 7 2s are 14, 7 3s are 21, 7 4s are 35, 7 9s are 63. So this will be now I write here. So what is that? 2R2 minus 7R1. This will be again 2 3 5 9, 2 3 5 9 as it is. 0, 6 minus 21 is minus 15, minus 4 minus 35 is minus 39, and 16 minus 63 is how much? See, 14 minus 14 0, 6 minus 21 is minus 15 minus 4 minus 35 minus 39, and 16 minus 63 is minus 47, and this will be 0, 0, right, lambda minus 5 and mu minus 9. Okay, so I think we are done here. Now the next is the conditions. So what I am asking now, see, my main aim was here to make this all 0, correct? I made this all 0. Okay, so this for x, y and z, 3 variables. Now they are asking first no solution. The meaning of no solution means what? It means no solution means rank of A is not equal to rank of A argument B, then only no solution. This is possible only when, see, if lambda is equal to 5 and mu is not equal to 9, in that case that implies rank of A will be equal to full. See, lambda is not equal to 5 means it will be 3 only, correct? And rank of A argument B will be equal to, if mu is not equal to 9, it will be, this will be, sorry, if lambda, that is only possible here, see, if when I want that both ranks are not equal, okay, this thing is rank A and this whole thing is rank B, A going B. So now if lambda is equal to 5 and mu is not equal to 9, in that case if lambda becomes 5, this whole row becomes 0, then rank of A will be 2 and rank of A argument B will be what? 3. In this case not possible, therefore rank of A will not be equal to rank of A argument B. So inconsistent and no solution. Now the second case is what's that? Unique solution. So unique solution is possible only when, there is no solution, unique solution is possible only when rank of A equals to rank of A argument B equals to n, the number of elements. That is only possible when lambda is not equal to 5 and mu is equal to not equal to 9, then only implies rank of A is equal to rank of A argument B is equal to 3, that is equal to number of variables n, x, y, z, n. In this case it is consistent and unique solution. You have to write a 3, okay. And the last case is what? Infinite solutions. So infinite solution is possible when rank of A equals to rank of A argument B and that is lesser than n. That is only possible when lambda is equal to 5 and mu is equal to 9. If both are equal, then only rank of A equals to rank of A argument B, that equals to 2 lesser than 3 n. So infinite solutions. That's all. Okay, fine. This is how we solve it. So you have to underline this. No solution means lambda is equal to 5, mu not equal to 9. And here lambda is not equal to 5, mu is not equal to 9. And here lambda is equal to 5 and mu is equal to 9. Compulsory underline it for the solution. Now the next one is solve by Gauss elimination method. Let's solve this also. Question 10b, Gauss elimination. So the question is 2x plus y plus z is equal to 10, 3x plus 2y plus 3z is equal to 18 and x plus 4y plus 9z is equal to 16. So 2x plus y plus z is equal to 10, 3x plus 2y plus 3z is equal to 18 and x plus 4y plus 9z is 16. We write A argument B as equal to 2, 1, 1, 10, 3, 2, 3, 18, 1, 4, 9 and 16. So again the concept here is making use of this one, we make making use of this 2, we make this 1 and 3 zeros. So multiply this by 2, 2, 8, 18, 32. Correct? 2 and the 2, 2 for the 8, 2 and the 18, 2, 16 the 32. So 2 R 3 minus R1. So this will be now 2, 1, 1, 10, 3, 2, 3, 18, 0, 7, 2 minus 2, 0, 8 minus 1, 7, 18 minus 1, 17, and 32 minus 10 is 22. The next is we need to make this 3 0 making out 2, so multiply by 2 and multiply by 3. 2 3s are 6, 4, 6, 36, 6, 3, 3 and 30. So 2 R2 minus 3 R1. So this will be equal to now again 2, 1, 1 and 10 as it is, 6 minus 6 0, 4 minus 3 1, 6 minus 3 3 and 36 minus 36. Am I right? 1, 3 and 6, okay, 0, this will be 7, 17 and 22 as it is. Lastly, we need to make this 7 0 making the 1, so simply multiply by 7 here, so 0, 7, 3 are 21, 7, 6 are 42. So R3 minus 7 R2. So this will be now 2, 1, 1, 10, 0, 1, 3, 6 and 0, 0, 17 minus 21 is minus 4 and 22 minus 42 is minus 20. That's all done. Okay. So the concept of Gauss elimination is below the principal diagonal make all the 0. So this is for x, y and z. Now by Gauss elimination method we can write, see x, y, z, right, 0x plus 0y minus 4z is equal to minus 20. So z is equal to 4 5 are 25. Put in second row, so y plus 3z is equal to 6, y is equal to 6 minus 3z, that is 6 minus 15, that is y is equal to minus 9, and lastly 2x plus y plus z is equal to 10, so 2x is equal to 10 minus y minus z, that is 2x is equal to 10 minus plus 9 minus 5, so 14, so x is equal to 7. So by Gauss elimination we can write x is equal to 7, y is equal to minus 9, z is equal to 5. That's all. So that's the solution. Okay, done. So now moving to the last question is find the eigenvalues and eigenvectors for the matrix. This problem I already solved. So please refer the link in description. So that's all. Okay. So I wish this was helpful. So again, as I tell you, I am uploading now. As I know there is less time left, but still you can make it. Okay. Solve the model question paper perfectly. Give it around 3 to 4 hours time. Solve it along with the other problems which are given on my Facebook and Instagram account. And please do refer my YouTube videos. Okay, it will be very beneficial. So that's all for today's video. Again, I request you to send your question papers after finishing the exam. Send your question papers on my WhatsApp number or my email ID. So that's all for today's video. I wish you best of luck for the exam. Stay confident, practice well. Still there is time. Okay, with the best resources you can easily get 80 to 90 or 100% of marks. Okay, so best of luck for you all once again. See you in the next semester. Till then, bye.